So in this question, well, before I know you can see distance, speed, and time, but I want to show you how do we know when we are looking at the question that I'm dealing with distance, speed, and time formula. So let's read. The airplane flies d kilometers out to a jump site at an average speed of x kilometers per hour. So there is a jump site somewhere. I like drawing. It kind of makes sense for me. So there is a jump site and there is a plane. Now watch me draw a plane. There is a plane and that plane flies towards the jump site. And we are told it flies d kilometers, so a specific number of kilometers, at a speed of x kilometers per hour. And then it then flies d kilometers, so the same distance back from the jump site. So then it flies back. So again, d kilometers. Throughout the return journey, so when he's coming back, its speed is 10% less than x kilometers per hour. So if it is 10% less, then he is flying only at 90% of what he did before. So here we can say at 0.9 x kilometers per hour. Okay. Now, we have really not much numbers here, isn't it? And then they are telling us to find percentage increase in the time it will take for the return journey. Yes, it will take longer because he is flying slower on the way back. So it will take longer, and therefore they are saying, what is the percentage increase? Okay, first, percentage increase. So when we are doing calculation of percentage increase or decrease, the same thing. And I, as you know, if you're watching my videos, I like to make things very simple, not sophisticated. So I consider two values, old number or old value and the new value. That's basically, doesn't matter the scenario. We take the old value and the new value. So in our case, the old value is what? This is the old, isn't it? That's because that's the first trip. And then the new is this one because it's happening after the first trip, isn't it? That's as simple. Now, if you, in some cases, it will be new minus old. If you want to avoid the negative value, you can put absolute bracket on top. Or even if not, you know that even if you're getting a negative value, it's a positive that you're going to take. That's the main thing from here. And like I'm saying, doesn't matter the scenario. It's about the number before and the number after, or the old number and the new number. That's basically what it is. Now, so we are mentioned the distance, the speed, and then we have to find actually the time when it comes to that percentage. So that is where we have our formula of distance, speed, and time. How do we know it's not about the function? Because we are not given a function. It's not about derivative. It's not about the integration. We are not given that. That's why, that's how we know it's just distance, speed, and time formula. So here, because we are dealing with time, so let's identify time that is old, so the beginning, and time that is new, because we don't really have numbers, so we have to deal with letters. So what is the old time? Distance divided at speed. The distance is what? D divided by speed of what? X. What's the new time? Distance is the same d, but speed is 0.9x. Okay, now really what this calculation is about, it's algebra, it's fraction. Let's work it. So we are taking our old time, which is d divided by x minus the new time, which is d divided by 0.9x. And everything is divided by the old value, which is d over x. Now you're wondering, how do I solve that? Okay, so each of those values, each of them have d. Therefore, I am saying I can divide each of these values by d. So I know that sometimes when they are numbers, it's sometimes difficult to see that. But think about it. If each number had 2, well, then I can divide each number by 2, isn't it? So that's the same idea. Now, let me rewrite it slightly differently. Maybe that will help you. When you have a fraction, always what you have on top of the fraction, you can bring beside the fraction. So now look at that. If I write d beside the fraction, divide by d goes, divide by d goes, divide by d goes. Yeah? So that makes it very clear. Okay, so let's see what are we left with. So we have 1 minus x minus 1 over 0.9x on top of the fraction, bottom of the fraction 1 over x. How do I deal with that? Well, I need to get one fraction on top. So what do I need? Common denominator. How do I do that? This x is multiplied by 0.9. So in order for this to be the same, I have to multiply that by 0.9, but that means I have to multiply the top by 0.9. So now I can write 0.9 by 1, that's just 0.9 minus 1, and everything divided by 0.9x. And all of that is divided, so let's put divide line by my x 1 over x. Now, when I'm dividing fraction, what do? I multiply. Well, that's at least the way I teach. I know that some people look at it differently. That's fine. Whatever works for you as long as you got it right. So we multiply and turn this one upside down. So in this case now, this x simplify with this x because I have a multiplication sign here. Yeah, if it was plus and minus, can't do that. But I have multiply, so I can. So that means that I am only left with numbers. I have 0.9 minus 1 on top of the fraction and 0.9 at the bottom of the fraction. Now, when we put that in the calculator, we're going to get negative value, 0.111111. Now, that's the reason why I said if that is in absolute value bracket, you're not going to get that. But as long as you know it's the positive number you are taking. So that's all what you have to remember. And we have to give percentage and percentage to one decimal place. So to change decimal into percentage, we multiply by 100 or move decimal 2 places, isn't it? So 11.1%. That's the answer here.